Welcome back to Hardware Unboxed. Today we're taking a deep dive into Intel's XeSS technology to see whether it's worth using on Nvidia and AMD hardware. Upscaling technologies are such a hot battle right now and continue to form the cornerstone of a GPU vendor's feature stack, with Intel now throwing their hat into the ring with XeSS to compete directly with Nvidia's DLSS and AMD's FSR.
Today's sponsor spot is brought to you by ASUS's new high-performance tough gaming GeForce RTX 4090 OC Edition graphics card. Having recently tested this model, I can comfortably say it's one of the very best 4090s out there. Wrapped in an all-aluminium fan shroud, it provides a premium look and feel, while the massive heatsink beneath delivers cool load temperatures along with whisper-quiet operation. Then, for gamers who like to go truly large, and I mean large, there's the ROG Strix version, offering class-leading performance and excellent thermals. So for more information, please check the link in the video description.
XeSS, or Xe supersampling, is very similar in principle to DLSS and FSR. It's a temporal upscaling algorithm that is designed to run games at a lower render resolution before upscaling them to your display's native resolution, improving performance with the goal of just a minimal loss to quality. The algorithm being temporal means that XeSS uses data from the current frame as well as past frames to reconstruct the image, which gives the algorithm more information to use at the cost of needing to be integrated into the game engine itself. The way XeSS works is more similar to DLSS than FSR, as Intel are claiming to use AI technology to enhance XeSS's reconstruction abilities. XeSS uses what Intel says is a neural network trained to deliver high performance and exceptional quality. However, unlike DLSS, which is designed to run its neural network only on Nvidia's Tensor cores, Intel are not locking down their XeSS technology to their own Arc GPU hardware. Instead, XeSS features multiple components and pipelines that allows it to run on Intel GPUs as well as GPUs from AMD and Nvidia. On Intel GPUs, XeSS is said to boost performance and possibly image quality through optimizations for Arc's XMX hardware block. On other GPUs, the tech uses a fallback to DP4A and other instructions. But basically, the goal here is to offer an open, AI-based temporal reconstruction algorithm that works on all GPUs, a direct competitor to FSR's non-AI-based approach that also supports all GPU hardware. XeSS is integrated into games in a very similar way to DLSS and FSR, and it even offers similar quality options that conform to the current standard the other vendors are using. There's a quality mode using a 1.5 times scale factor, a balanced mode at 1.7 times scaling, and a performance mode at 2.0 times. This means that when targeting a final 4K resolution, XeSS, like DLSS and FSR, will actually render the game at 1080p using the performance setting. In addition to this, Intel offer an ultra quality mode with a 1.3x scale factor, something not typically seen from DLSS and FSR implementations. Intel have also discussed an ultra performance mode option at times, although this wasn't available in the games we tested for today's video. For today's testing, I first want to explore how XeSS performs. This will set the baseline for visual comparisons so we can match up the relevant XeSS setting to DLSS and FSR, all providing the same performance boost. For this video, I wanted to focus on GPU hardware gamers might actually own, in other words, Nvidia and AMD GPUs, before looking at Intel hardware in a future video. There's already so much to go over just looking at XeSS on Nvidia and AMD that any potential improvements specific to Intel really should be left to its own investigation. All testing today was conducted on my Ryzen 9 5950X test system with 32GB of DDR4 3200 memory. Later in this visual quality section, you'll see 4K captures taken on a GeForce RTX 3080 to ensure consistent 60 FPS across all of the samples. But for the performance section, I wanted to use hardware that's more limited and benefits the most from upscaling technologies at multiple resolutions. After all, we can't benchmark a wide variety of graphics cards in these sorts of videos, as testing even one GPU at 3 resolutions with up to 11 quality settings is quite time consuming. So I've chosen to use the GeForce RTX 3060 to represent Team Nvidia and the RX 6650 XT on Team AMD, both current generation mid-range mainstream options. Latest drivers and game versions were used, so let's get benchmarking. Going to start off here with Hitman 3 using ultra settings but no ray tracing on the RTX 3060 at 4K. Already the results are quite interesting. Intel's XeSS Ultra Quality mode offers basically the same performance as native rendering, despite using a 1.3 times scale factor. It seems that the advantage of rendering at a lower resolution is eaten up entirely by the overhead of the XeSS upscaler at this resolution and quality setting. The next step down in quality is also interesting. XeSS quality runs slower than both DLSS 2 quality and FSR 2 quality. On the DLSS side, it's actually the XeSS balanced mode that matches DLSS quality in performance, while on the FSR side, FSR quality sits between XeSS quality and balanced. Then for the XeSS performance mode, we only see a performance uplift equivalent to DLSS or FSR balanced. XeSS performance provided a 38% uplift over native rendering, whereas DLSS performance gave a 60% uplift and FSR performance a 58% uplift. At 1440p, it's a similar situation in Hitman 3. The closest XeSS setting to DLSS and FSR quality modes was the balanced option, and the performance mode only matched that of DLSS or FSR balanced, with DLSS performing the best of the three upscaling techniques. At least with this resolution, XeSS Ultra Quality did provide a small 6% performance uplift over native rendering. At 1080p, again similar results, DLSS or FSR quality matches up with XeSS balanced, DLSS or FSR balanced matches up with XeSS performance. We typically don't recommend gamers use upscaling at 1080p, and Hitman 3 is no exception with the RTX 3060, as the game, at least in this benchmark, is already running at over 140 FPS natively. The results are surprisingly different when we move over to AMD's Radeon RX 6650 XT. XeSS performs categorically worse on RDNA 2 hardware than it does on Ampere. When using the XeSS Ultra Quality setting, we actually see a performance regression at 4K compared to native rendering, and now only the quality setting is able to match the performance of native. This causes big implications for the comparison between XeSS and FSR. We needed to turn XeSS all the way down to the performance mode to match the FPS of FSR running using the quality setting. Ouch. This also holds true at 1440p. XeSS quality runs a little better than native here, but it's not a great showing compared to FSR, given that FSR quality offers a 20% boost in performance over native rendering, but XeSS quality only manages a 4% boost. We see the same behavior at 1080p, where again the ultra quality mode reduces performance and the quality setting is only a minor bump. In Spider-Man Remastered, we're back on the RTX 3060 now to look at 4K performance using max settings without ray tracing. This is a perfect candidate for upscaling as the game only ran at 43 FPS on average natively, so upscaling is a great choice to hit 60 FPS. However, like in Hitman 3, XeSS is a notch below DLSS and FSR in the performance uplift it brings. DLSS or FSR quality mode is only equivalent in performance to XeSS balanced, while DLSS or FSR balanced equals XeSS performance. At 4K on this Nvidia GPU, the ultra quality mode essentially delivered the same performance as native rendering. At 1440p, the results are more dire for Intel's upscaler. At this resolution in Spider-Man, only the XeSS performance option was able to match DLSS's quality mode, while XeSS balanced matched FSR quality. While XeSS quality and balance did provide an uplift compared to native rendering, it just wasn't that impressive compared to DLSS. Meanwhile, at 1080p in this title, upscaling is not effective, at least on the Ryzen 9 5950X. In Spider-Man, XeSS is disastrous on the RX 6650 XT at 4K. All quality settings delivered worse than native performance, although the performance mode did roughly match that of native rendering. For some reason, XeSS really choked up on this GPU here, and the results surprised me given at least a few options were viable in Hitman 3. Unfortunately though, FSR is simply far better at delivering a performance uplift here, with its quality mode delivering a 26% performance improvement compared to a 21% performance regression using XeSS quality. Thankfully, XeSS is more effective at 1440p on the 6650 XT. While the performance mode here is only able to match FSR quality, at least the settings from quality and lower do provide a performance benefit relative to native rendering, and it's only the ultra quality mode that sees no benefit. Similar to the RTX 3060, there's no point upscaling at 1080p in this title. The third and final game we're looking at in today's video, we've used the three main games that offer all of DLSS 2, FSR 2, and XeSS upscaling, is Stranding Director's Cut. In this title, XeSS doesn't look so flash even on the RTX 3060. At 4K using very high settings, XeSS Performance Mode was the only setting to offer comparable performance to DLSS quality, while XeSS Balanced matched up with FSR quality. The Ultra Quality mode also offered a performance regression here compared to native rendering, to a greater extent than what we saw in Hitman 3. Meanwhile, at 1440p, XeSS is functionally useless on the RTX 3060. The performance mode here is only able to match native rendering, while both DLSS and FSR provide a performance uplift. Not a substantial performance uplift by any means, but at least some sort of increase. On the RX 6650 XT, XeSS in Death Stranding is a bit better at 4K relative to Spider-Man. However, XeSS still runs slower than on the RTX 3060 relative to FSR. Here on AMD's RDNA 2 GPU, XeSS Balanced was only able to match native rendering, with both the Ultra Quality and Quality modes providing a performance regression. Meanwhile, FSR2's quality setting is able to outperform XeSS performance. At 1440p, both FSR and XeSS do hit a wall in performance, FSR providing about 120 FPS, while XeSS delivers less than 110 FPS. I think this does illustrate well that XeSS is a more intensive upscaling technique on GPU hardware, so whenever these sorts of walls are hit, the overhead of XeSS tends to cost gamers more performance than using the comparatively lighter weight FSR algorithm. In this situation, FSR provides a performance uplift, while XeSS sees performance go backwards slightly. The performance data we gathered here is certainly pretty illuminating into how XeSS runs on Nvidia and AMD hardware, and I certainly wasn't expecting such a discrepancy between the two main GPU brands. Even though the RX 6650 XT offered better native performance in 2 of the 3 games, XeSS consistently ran worse on RDNA 2 than Ampere and delivered a lower performance uplift than FSR2. In some cases, it was basically useless as all modes offered lower FPS. XeSS ran okay on the RTX 3060, but wasn't able to match either DLSS or FSR at the same render resolution. This makes visual quality comparisons a little bit trickier than I was expecting. On Nvidia hardware, if we normalize for performance, the matchups are typically as follows: XeSS Ultra Quality versus Native, XeSS Balanced versus DLSS and FSR Quality, and XeSS Performance versus DLSS and FSR Balanced. However, XeSS in Death Stranding runs worse than this, so those are almost a best case scenario. On AMD hardware, performance was more variable, though typically XeSS performance matched up against FSR quality. In some instances, XeSS didn't even match native rendering though, so that's something we'll have to keep track of when exploring the visual differences. Let's get into them now. Our first matchup here is Hitman 3 at 4K with an Nvidia performance normalized battle pitting DLSS quality and FSR quality up against XeSS Balanced, showing the opening cinematic from the Dubai level. There's no sharpening slider available here, and DLSS uses the most aggressive sharpening of the 3, so its image tends to look the sharpest. DLSS also has the best image stability and best reconstruction of fine detail, although at times FSR2 is slightly better for reducing aliasing on fine wire details. At times, XeSS looks okay and can deliver better fine detail reconstruction than FSR that's a bit closer to DLSS. However, this is offset by lower image stability and in particular, visual artifacts that are noticeable without zooming in. XeSS doesn't deal with volumetric lighting as well as FSR, or particularly DLSS, and in this final scene, there's some really horrible flickering with XeSS that isn't present with either of the other reconstruction techniques. On AMD GPUs, we have to compare XeSS performance to FSR quality in this title to get an accurate look at performance normalized visuals. This further hurts XeSS compared to what we saw in the Nvidia comparison. The XeSS performance mode just isn't very good and exacerbates any flickering and image stability we previously saw. This is clear right from the early parts of this cinematic where you'll see reflections flicker, and any time I found an issue with the FSR image like aliased fine details, typically that issue was worse with XeSS. Even when we put XeSS up against FSR at the same quality setting, in this case the quality mode both rendering using a 1.5 times scale factor, XeSS isn't always better. It does have better image stability at times and better fine detail reconstruction, but it still suffers from jarring artifacts that FSR2 just doesn't have. Considering it also runs worse in this configuration on both the RTX 3060 and RX 6650 XT, it's hard to recommend. Next scene is Hitman 3 gameplay with FSR and DLSS quality modes up against XeSS balanced. This alleyway has a lot of fine detailed elements like wires, mesh and cages, which all favour DLSS reconstruction. Not only is the DLSS image sharper, perhaps too sharp, but it deals with all of these fine details the best of any technique. Clearer lines, less flickering, better image stability. XeSS versus FSR is a more interesting battle here, with the image quality trading blows depending on where you look. Despite rendering at a lower resolution, XeSS does a better job of reconstructing some fine elements. There's more rain present, for example, which looks more like the DLSS image. However, there are clearly some issues with how XeSS is handling the reflections with distracting flickering and a low resolution appearance. FSR is doing a much better job here of delivering a like-native presentation, similar to what DLSS is doing. When viewing the differences in an AMD performance normalized condition, XeSS suffers badly from having to drop the quality setting down to performance mode, which matches FSR2 quality mode. All of the artifacts we've been talking about are amplified and more are introduced. For example, I no longer believe XeSS in this configuration is as good as FSR at reconstructing fine detail, with more shimmering noticeable in the XeSS image. Couple of quick comparisons before we move on to the next game. Here's our Nvidia configuration looking at the Dartmoor benchmark, which shows off particle effects nicely. Again, DLSS 2 has the best image quality here, but I think XeSS Balanced does a decent job of reconstructing all the particles with less sizzling and a higher level of quality than FSR2's quality mode. I don't think FSR looks terrible or anything, but in my opinion quality was noticeably lower than XeSS in this scenario. This is also true in our AMD configuration, pitting FSR quality against XeSS performance. The particles still look decent on the XeSS side, but when looking at other areas, the image quality issues with the performance mode are noticeable once more. The final example I wanted to show is an area where XeSS actually outperforms both DLSS and FSR visually, and that's this laser show from the Hitman 3 Berlin level. XeSS does a better job of reconstructing the moving laser beams than either of its competing technologies, despite a lower render resolution used for this performance normalized comparison. The XeSS lasers look like a nice consistent beam, while the DLSS lasers are very aliased and the FSR lasers are blurred and less visible. A good result for Intel's upscaling technology. Moving over now to Spider-Man Remastered, and we'll start with a walking comparison using our Nvidia configuration. Lots of foliage in this scene, and honestly it's pretty hard to spot any major differences with any of the three rendering techniques. For the FSR and DLSS images I had sharpening set to 5, which ended up making DLSS look a bit sharper and perhaps too sharp. Meanwhile, XeSS doesn't allow sharpening adjustment and looks the softest as a result. DLSS had the most stable image with the least flickering and aliasing, though this wasn't much of a concern with FSR or XeSS either. For our AMD configuration, I've included here three visual options. We've got native, FSR quality, and XeSS performance. This is because on the 6650 XT at 4K, XeSS runs similarly to native performance, but we're also interested in seeing how it compares to FSR using its highest quality mode, which also runs the best out of these three options. Now, native clearly looks the best here, although FSR quality also looks respectable given it delivers higher performance. However, it's hard to make a case for using XeSS performance mode here. Not only is the image less detailed, it's also less stable with weaker fine detail reconstruction and occasional flickering. We're not seeing artifacts that dominate the screen, but I wouldn't choose to use XeSS in this configuration. Out of interest, I swapped out the FSR quality footage for FSR performance, giving us a look at FSR versus XeSS both at a 1080p render resolution. It's a much closer battle here visually. XeSS has some shimmering issues on fine details, while FSR has some sizzling around Spider-Man. I think the XeSS footage has a small advantage here, but you'd really hope that was the case given FSR ran about 40% faster. Naturally, a big part of a Spider-Man game is swinging around the city, so let's look at that. You'll have to excuse the syncing of the footage, which is very difficult for this type of gameplay. In our Nvidia configuration, the DLSS image looks the best here, no doubt about it, even if we ignore the sharpness differences which are configurable. DLSS has the least ghosting, the least shimmering, least sizzling, and the best image stability. At times it's only a small advantage in favour of Nvidia's reconstruction, but it's something I notice playing the game. For the other techniques, I want you to focus on two areas which may not have been apparent on the first playthrough of the footage. The FSR quality image has trouble reconstructing Spider-Man's swinging web. There's a bit of ghosting and sizzling around that element as the web occludes various objects on the screen. It doesn't look amazing. This isn't as much of an issue with the XeSS image, however XeSS has its own problems. If you focus on the buildings in the background, the XeSS image has noticeable flickering when reconstructing the windows. And while there's a bit of flickering in the FSR presentation as well, it's much more noticeable and jarring on the XeSS side. Now in our AMD configuration, I've put XeSS performance side by side with FSR quality. Now yeah, this may not be a fair comparison as FSR performs better in this configuration at 4K, but it does highlight the issues XeSS has on AMD hardware. The visual quality just isn't great using XeSS in this way, and I would choose FSR instead every single time, despite some issues with the FSR presentation. Image stability is an issue with XeSS even when you're not moving. Take this scene on a rooftop. In our Nvidia performance normalized configuration, XeSS shows clear flickering and issues without any movement on screen at all. DLSS is very stable and looks excellent. FSR has some minor stability problems for fine details, while XeSS looks pretty bad. It's only when we swap out the XeSS bounced footage for XeSS quality does image stability improve to a similar level to FSR, so with all rendering at the same base resolution, it's a much more favourable comparison for XeSS. However, if we then normalize for performance on an AMD system and compare FSR quality to XeSS performance, it's once again not a good showing for Intel's technology, and really it's the slow performance of XeSS on RDNA 2 that kills its usability. Were XeSS and FSR able to deliver similar levels of performance at each respective quality level, XeSS would be much more usable. But performance normalized FSR is definitely the way to go. XeSS also looks the worst when we have all three techniques using their performance mode. DLSS is clearly the most stable and looks the best. No motion in performance mode is one of the strengths of DLSS. FSR is a bit unstable, not ideal here considering image quality is reduced relative to the quality mode without any motion, but XeSS has the least image stability and the most flickering. Our final look at Spider-Man is climbing this brick wall, which is an excellent test for ghosting. In our Nvidia performance normalized configuration, it's pretty obvious that DLSS is handling motion the best, with the least amount of ghosting. There is still a small amount of ghosting, but it's difficult to spot in real gameplay using the quality mode. FSR and XeSS on the other hand are not great. Especially when we jump down from the top of the building, FSR has moderate ghosting that's clearly visible in real time, while XeSS has severe ghosting that looks absolutely atrocious. When we slow down the footage, you can see that not only does the XeSS image have a huge ghost trail, the brick texture work is blurred too. XeSS really struggles with this and simply doesn't have the optimization that DLSS has. And yes, before you ask, this is the case even if we use the same quality preset for the three reconstruction techniques. This scenario was perhaps the most noticeable difference I'd seen comparing XeSS to FSR and DLSS in Spider-Man, and it crops up in many places that aren't just this specific example. Both AMD and Intel need to put in work to reduce ghosting in these situations. The last game example we have is Stranding, which presented the worst performance for XeSS relative to DLSS and FSR of the three games that we looked at. In this game, when performance normalizing for an Nvidia configuration, we have to compare DLSS quality to FSR balanced and XeSS performance, which is not very favorable to XeSS. This game is a great showing for DLSS, as on the RTX 3060 it had a clear performance lead on the other technologies, which allows it to be run at a higher render resolution in these performance normalized comparisons. Everything we've been saying about DLSS throughout this video is true in Stranding as well. Better image clarity and stability, which depending on where you look ranges from a minor to moderate advantage. Overall stability wasn't significantly better than FSR at times, but there was a large difference compared to XeSS, which had to be run in its performance mode to achieve a similar frame rate. As we've shown several times now, the XeSS performance mode is not very good, and I wouldn't recommend using it as it produces a lot of artifacts. Not only that, but in this game, XeSS performance appears to reduce the quality of some textures relative to the other modes as well, which may indicate an issue with the way the technology has been implemented. However, it's not all bad for XeSS. FSR is also not great in Stranding, even though the director's cut provides FSR too. There is lots of ghosting present in the FSR image that isn't visible in either DLSS or XeSS. Unlike in Spider-Man, where XeSS had the most severe ghosting, it's FSR with the problematic ghosting in this title. Even in these comparisons though, XeSS can't match DLSS. Normalizing performance on an AMD system pits FSR quality mode up against XeSS performance mode once again, and honestly, I'm not a huge fan of either presentation. XeSS is the worst of the two with noticeable artifacts and image stability issues across the whole screen, but FSR2's ghosting I also found quite annoying. Really, in this game, you should be trying to run at native resolution, which is pretty achievable in this title, even using modest hardware. Last visual comparison is looking at Death Stranding's BTs, which have a lot of particle effects and movement. Here I've normalized for quality settings, so we're looking at DLSS quality versus FSR quality versus XeSS quality, all rendering at the same base resolution. A best case scenario for XeSS, given it runs the slowest here on both AMD and Nvidia hardware. DLSS once again looks the best of the three reconstruction techniques. It handles this effect really well, so we end up with nice amounts of particles and minimal distortion. FSR does okay, but it's not amazing, and inferior to the DLSS presentation. Some particles are preserved, but there's some artifacting as well. XeSS though clearly looks the worst. Intel's reconstruction is blurring the BTs and removing a significant number of particles, and that's despite using the quality mode here. XeSS really does not like to handle this situation in motion, blurring the BTs massively in comparison to the other techniques. So that's the image quality and performance analysis done. What to make of Intel's Xe supersampling? Well, for those of you who have Nvidia or AMD GPUs, which let's be honest, make up the vast majority of desktop PC gamers, there's really no reason to use XeSS at all. Intel's upscaling technology performs worse than Nvidia's DLSS 2 and AMD's FSR 2 at the same render resolution, and in most situations it produces worse visual quality as well. It's a bit of a brutal double whammy here, which is really disappointing given what the technology was promising to do. For those with an Nvidia RTX GPU, there is categorically no reason to use XeSS when other techniques are available. DLSS is the obvious choice. It delivers the best performance uplift across the games we tested and the best visual quality. DLSS 2 is in a really nice spot right now in terms of its optimization, so we noticed the least amount of visual artifacts using this technology. It's a no-brainer for Nvidia RTX owners. DLSS is the way to go if you want a performance boost. For those who don't have an RTX GPU, whether that's an AMD Radeon owner or a GeForce GTX owner, there's also little reason to use XeSS. On RDNA 2 hardware as an example, XeSS runs badly and is at a disadvantage up against FSR 2. It's common for XeSS to reduce performance relative to native rendering using the quality or ultra quality modes, leaving performance parity with FSR 2 in a bad spot, where the performance mode only matches FSR 2's quality mode. Under these circumstances, XeSS looks worse than FSR most of the time. But even if we used the same quality settings across DLSS 2, FSR 2, and XeSS, I'd often place XeSS in last place for visual quality. Intel's upscaler has issues with visual stability and artifacts that are less prominent with FSR and basically a non-issue with DLSS. XeSS does handle fine detail reconstruction better than FSR at times, and the overall presentation is far better than, say, a DLSS 1.0 as an example, but too often my gaming experience was impeded with distracting temporal issues. It's just not good enough to have more visual issues and worse performance than other options available to gamers when making an upscaler that's available to all GPU owners. As XeSS isn't worth using on AMD and Nvidia GPUs, it's also not worth integrating into games. Developers would be better placed spending their time elsewhere, whether that's optimizing the DLSS and FSR implementations or just working on something else. Even if XeSS did work better on Intel GPUs, something we'll be exploring soon, the user base for Intel Arc is so small that it's really not worth considering. To make matters worse, Intel are yet to convince us their Arc GPUs are worth buying, with mediocre value and driver issues with their first generation lineup. I think XeSS also serves as good evidence that integrating AI technology isn't always the savior on its own. At launch, FSR 2.0 was criticized for not using AI tech, instead opting for a handcrafted algorithm. That criticism looks a bit silly now because as it stands, FSR 2 is superior to XeSS on the majority of GPU hardware we have today. If you want to use AI to enhance upscaling, it needs to be combined with an excellent algorithm and plenty of optimization, which is what Nvidia has done with DLSS 2. Simply training and integrating a neural network isn't sufficient, especially if that neural network slows the algorithm. What can Intel do to improve XeSS and make it worth using? Well, the big one is resolving visual artifacts. Intel need to stamp out flickering and ghosting and produce a much more stable presentation, especially using the lower quality settings. On top of that, Intel need to significantly improve performance on Nvidia and AMD hardware as well, so that XeSS performs as well as FSR2. If XeSS is to survive as a technology, it needs to offer something better than FSR2, and right now they are behind in both key areas. Only after even matching FSR2 should Intel begin thinking of tackling DLSS2, because right now they aren't even that close to Nvidia's AI upscaling technology. At the end of this testing, I've come away thinking XeSS is a bit of a fail. I understand that these days companies do need a strong feature set to sell their GPUs, and that XeSS was actually announced before AMD's FSR2, but the end result has turned out a bit pointless. FSR2 is already playing the role that XeSS was set to fill, putting Intel behind the 8 ball. Hopefully they can improve XeSS to the point where it's a really strong competitor, but there's a bit of work that needs to be done, that's for sure. Anyway, that's it for this detailed XeSS analysis. Like I said, we will be back at some point soon to take a look at how XeSS performs on Intel's Arc GPUs, probably using the A770. We have heard some claims that perhaps not only is performance more optimized for XeSS on Arc GPUs, but also that it may look a bit different. I'm not sure on that one. We'll take a look soon. So stay tuned for that one. Subscribe so you get that video into your inbox. If you want to support our independent testing of technologies like this and also DLSS 3, which we recently looked at on the channel as well, then please do consider supporting us on Patreon or Floatplane. Links to those are in the description below. You gain access to cool benefits like our Discord community, which is a great place to chat about all the latest goings on in the technology space. So thanks for watching, and I'll catch you in the next one.